the first thing we're going to talk about are graphing lines. All right, graphing lines. So they've given us this function x plus 5, y equals x plus 5. And so if you recall, the first way that we did graphing was to make a table. And so that's what they've done here. They've made a table. They have chosen -2, -1, 0, 1, and 2 as their x values. To get their y values, they've just plugged it in. -2 plus 5 is 3. So the point that they got here was -2, 3. -1, they plugged in. -1 plus 5 is 4. So the point they got here was -1, 4. And they did that all the way down. And if you were to graph these points, so if I go to -2, 3, and -1, 4, 0, 5, 1, 6, 2, 7, hopefully you will notice that we are forming a line, okay? And so if you pick any points, it doesn't matter what points you pick and plug it into that equation, you are going to get this line. All right? And so you plot the points and you notice that it is a line. Connect the points and you'll notice that I also put dashes on the end of it. And these are the steps that you are going to use to graph this particular one. But this is actually a special type of function. This is called a linear function, They've written it two different ways. You'll notice that they wrote it with the f of x. All right, and so they have f of x there. And they also have a y. Those mean the same thing. It's just different ways to write it. X is a function of y. Or y is a function of x. And so that's how they've written it, f of x and y. They are called linear functions or linear equations because all the points that satisfy them form a straight line. By definition, all lines are straight, but they form a line, okay? And so a linear equation, when you graph it, will always form a line. The first form that we are going to talk about is called standard form. Standard form. The standard form of a linear equation is ax plus by equals c, where a, b, and c are real numbers. Several different standard form equations are possible for the same linear function. I will say that you will also typically see it with no fractions. So I'm going to show you how to take out the fractions. And you'll also see it where your a is positive. And so if your a is ever negative, then we're just going to multiply everything by -1. And that's how you have a standard form of an equation. All right, and so the first thing we're going to do is we're going to take an equation for a line and we're going to change it to standard form. So look at the top of page 233 at example 2. Top of page 233 at example 2. It says, write this function as a linear equation in standard form. So the first thing we're going to do is we're going to rewrite this f of x and we are going to put a y there. Remember, those are the same things. So we're going to write, instead of f of x, we're going to write y equals -5 over 7 x plus 2. Now you'll recall standard form has the x and the y on one side, and it has the constant that does not have a variable on the right-hand side. And so what we need to do is we need to make sure that x and y are both on the left-hand side. Well, right now my y is on the right-hand side, and so I want to move this over. The way you move something across the equal sign is to either add or subtract. Just do the opposite. In this case, it's a -5/7. So I'm going to add 5/7 to the other side. Now, it cancels on the right-hand side. Over here, can I combine the y and the 5/7 x? No, I cannot. Why can't I? They are not like terms. Yeah, they're not the same variables. So I have 5/7 x plus y equals 2. Now remember I said that your a, b, and c are never going to be fractions when it's in standard form. So my problem here is that I have a fraction. So what I am going to do is I am going to get rid of my fractions. The way you get rid of a fraction is to multiply by your common denominator. Now 2 of them don't have a denominator, so technically it's a 1. So I really only have to worry about one fraction here. What is the denominator of this fraction? 7. So I am going to multiply every single one of these by 7. Okay? Every one of those I'm going to multiply by 7. When I do that, what happens here? Well, 7 times 5 over 7, you can cross cancel, can't you? Those both becomes 1s. So that actually just gets rid of my denominator altogether, and that becomes 5x. 7 times y, well, that's easy. That's just 7y. And then 7 times 2, that is 14. So this is what this looks like in standard form. That's what that looks like in standard form. All right? So we're going to start with just graphing this line here, the way that we know to graph. And remember, we typically graph by just making a chart. And so we're going to make a chart. We're going to choose some x's. We are going to plug it into our equation. But in this case, we need to solve for y. And so we can plug it into that standard equation if we want to, or we could solve for y, whichever is easier. It doesn't matter. But we need to get our y value. So we can either solve for it. If you look in the book, they just moved the x over. They divided everything by 3. Or you can just plug it in and solve for y. It doesn't matter. So if I choose 0, 1, and I think they chose 4. Plug in a 0. We don't know what our y is. We solve for our y. In this case, if we divide over, we're going to get that y is 4/3. So if my x is 0, my y is 4/3. Plug in a 1. 1 plus 3y equals 4. Subtract your 1, divide by 3. Your y is going to be 1. And then if we plug in a 4, subtract your 4, you get 0. Divide by 3, you still get 0, so we're going to get 4, 0. All right? Now, graphing 4/3 is kind of a pain. But when you're graphing a line, you actually only need 2 points. If you know it's a linear equation, all you have to do is graph 2 of those points. So I'm going to actually graph these 2. These bottom 2 right here, because 4/3 is a little more difficult to graph. So I'm going to graph my 1, 1 and my 4, 0. And once I have that, I can just draw the line. And it will cross 0, 4/3, but 0, 4/3 would have been a little bit harder to put down. 4/3 is about 1 1/3. So you'll see that it did cross there. But it's easier to graph the ones that fell on the actual crosses. So that's one way to graph, is to just make a chart and graph your linear equation. The y-intercept is the point where the graph crosses the y-axis or intercepts the y-axis. The x-intercept is the point where the graph intersects the x-axis. Right? So it's where it crosses the x-axis, crosses the y-axis. Those are called your intercepts. All right? So then how do you find it? Well, let's talk about crossing it. If I cross the x-axis, my value of y is what? What is my value of y anywhere on the x-axis? How much have I gone up or down? 0. Right? So when I'm crossing the x-axis, my y value is 0. What about my y-axis? When I cross this, what is my x value? 0. So to find it, you actually plug those in. So if I want to find my x-intercept, I am going to make the y value 0. So I'm going to say 2x plus 0 for my y equals 6. Well, that gives me 2x equals 6, x equals 3. So my x-intercept is going to be my x value of 3. My y value was 0. That is my x-intercept. If I want to find my y-intercept, I am going to make my x value 0. So now I'm going to make this x value 0. 2 times 0 plus that y equals 6. Well, that's just 0 plus y equals 6, so y equals 6. Which means my x-intercept, my x was 0, my y is 6. When you find your intercepts, you have found 2 points on the line, which means you can graph it. So I'm going to graph these points. 3, 0, that happens right here. 0, 6, that happens right here. And so if I connect those 2 points, I have the graph of my line. So another way to graph is to use your intercepts, specific points on the line. And I will say when it is in standard form, ax plus by equals c, I always graph this way. All right, so this was ax plus by equals c. What always happens for your x-intercept, this ends up being that c value divided by the number that was in front of your x, because you zeroed out your y. Your y always ends up being that c value divided by the number that was in front of your y. That always is your y-intercept when it is in standard form. And so anytime it's in standard form, this is always how I will graph it, because I can very quickly find my x and y intercepts, and in order to graph a line, you only need 2 points. And so your instructions will often say, find your x and y intercepts and then graph the line. And that's what they want you to do. Find those 2 points, then connect them. So let's try one of those. Find your x and y intercepts and then graph it. And I'm actually going to rewrite this in standard form, because that's how I want you to graph this one. Graph each equation, then determine if it is a function. These are special types of lines. All right. When you see that you are missing a variable, it is either going to be a vertical or a horizontal line. Okay? Always. And so for this, y equals -2. Y equals -2. That means everywhere on that line, my y value is -2, no matter where I am. So if I am at 0, my y value is -2. If I am at 6, my y value is -2. If I am at negative 8, my y value is negative 2. Y equals a number will always be a horizontal line at that number. All right, and so I go to negative 2 on my y-axis, and I just draw a line. It will be this horizontal line. That is the line y equals negative 2. All right, so then on the flip side of that, we have x equals a number. X equals positive 3. That means no matter where I go, my x value is going to be positive 3. So if I am at 0 for the y value, my x is positive 3. If my y value is 4, my x is positive 3. If my y value is negative 5, my x is positive 3. So when it's x equals a number, that is a vertical line. So I'm just going to go to that number on my x-axis and draw a vertical line there. Special cases. Now it asks, are they functions? Well, is this y equals negative 2 a function? Remember my vertical line test. If I were to draw a vertical line anywhere on it, am I going to cross it more than once? No. So that is a function. What about this guy? No. I draw a vertical line, I'm going to be on it. There are multiple values of y for that one x. So this is technically not a function. All right? It's a linear equation, but it is not classified as a function.